Iris tutorial. Achieve success and nothing else. We are going to discuss about human eye, class 10.
The human eye. We know that a lens is an optical device that transmits and refracts light. Our eyes too have lenses that enable us to see objects around us. Let us see how the eye is put together and how it works. At the very front of the eye is a transparent structure called the cornea that helps to focus incoming light. Behind the cornea is the iris. The iris has a circular opening called the pupil. The pupil expands or contracts depending on the amount of light entering the eye. Situated behind the pupil is a colorless, transparent crystalline convex lens surrounded by the ciliary muscles. The muscles hold the lens in place and help to change the focal length by adjusting the curvature of the lens. To view a distant object, the muscles relax, the lens becomes thin, and its focal length increases. To view a nearby object, the muscles contract, the lens becomes thick, and its focal length decreases. This ability to adjust its focal length is called the power of accommodation of the eye. The image formed by the lens is a real inverted image of the object that then strikes the retina. The light-sensitive cells in the retina convert the light into electric signals that are relayed to the brain. The brain converts these electrical signals into the images that we see. The minimum distance at which the eye can see objects clearly is called the near point or least distance of distinct vision. In a normal eye, it is 25 centimeters. The farthest distance up to which the eye can see objects clearly is called the far point of the eye. In a normal eye, it is between 25 centimeters and infinity. The eyes can gradually lose their power of accommodation, resulting in blurred vision due to refractive defects. There are 4 common refractive defects of vision that we shall look at and see how they can be corrected. The first defect we look at is hypermetropia, also known as far or long-sightedness, in which nearby objects cannot be seen clearly as the image is formed behind the retina. This is due to the increase in focal length of the lens and decrease in the length of the eyeball. This defect can be corrected using convex lens of suitable focal length. The next defect is myopia or short-sightedness, in which distinct objects cannot be seen clearly as the image is formed in front of the retina. This defect may be due to the increase in curvature of the lens or due to the increase in length of the eyeball. This defect can be corrected using concave lens of suitable focal length. The third defect we look at is presbyopia seen in elderly people. Here, nearby objects cannot be seen clearly due to the increase in the distance of the nearest point. This may be due to the weakening of the ciliary muscles or due to the decreased flexibility of the lens. This can be corrected using a convex lens of suitable focal length. At times, both nearby and distant objects cannot be seen clearly, and this can be corrected using bifocal lens. The upper part is concave, correcting distant vision, and the lower part is convex, correcting near vision. Astigmatism is another common problem seen when the image may be clearly focused on the retina in the horizontal plane, but not in the vertical plane. This defect may be due to an irregular curvature of the cornea or lens. This can be corrected using glasses with cylindrical lens. Things to remember. The ability of the lens of the eye to see near and distant objects by adjusting its focal length is called the power of accommodation of the eye. In hypermetropia, nearby objects cannot be seen clearly. This can be corrected by using a convex lens of suitable focal length. In myopia, far-off objects cannot be seen clearly. This can be corrected by using concave lens. In presbyopia, both nearby and distant objects cannot be seen clearly. This can be corrected by using bifocal lens.